Hello everyone, welcome to another Root Taps at lunch. My name is Bart Moens, and today we have Sam de Bruin. Sam will show us how we can set up a data lake in Azure using infrastructure as code via a Terraform module. Sam is a data engineer at Data Roots, and at the moment when he's not hosting webinars, building a data lake for one of our customers. The data lake is used to feed some machine learning models like a churn probability analysis and recommendation engine. Sam is also a Microsoft Azure certified data engineer and a certified Terraform cloud engineer. So if you have any questions, you can post the questions in the chat and we will visit these after Sam's presentation. The session is also recorded and will be posted on our YouTube channel. I will post the link to our channel in the chat. So Sam, we are ready for your presentation and demo.
All right. So today we're going to deploy a data lake without a lot of effort. You will only need to enter one command in your terminal and the full data lake and the data lake network will be deployed. We will do that using a Terraform module that we built, and it's available open source on our GitHub account. Before we dive into the data lake itself, let's talk about the design principles and the components that will be deployed. So we're working with Azure, so we only will use Azure Services. The principles is or that we prefer managed services over unmanaged services. They have a lot of advantages, especially in maintenance and access control after they've been deployed. And most of the time also in regards to pricing. Another important aspect of the services that we are picking are the SLAs, the availability and the redundancy. We don't want the data lake to go offline. We want it to be available all the time, and SLA is an important factor in that aspect. Another important aspect is scalability. We can start with one small data lake pipeline that just ingests data from a single source and outputs somewhere else after a few transformations. But the goal of every data lake is to scale and grow, and we have to make sure that from the start that every component is very scalable. So you have to make some compromises between functionality, performance, and pricing. Basically, you can always pick two, but then you sacrifice the other one. So you have to find a middle ground here, and that's what we try to do. The first service that we're using is Azure Data Factory. Azure Data Factory will be used for data ingestion. In this part of the data lake, we will be doing extract, load, and transform with a small t, because we only transform the file format of the raw data. When we ingest data, we won't transform the data as such, only the way how it's stored on our data lake. So that's that explains the small t. Why Data Factory? Data Factory offers tons of connectors out of the box for different sources, so you can connect it to a lot of Azure services, but they offer connections to, for example, SAP or an Oracle database as well, to Amazon Storage. You can basically connect a lot of sources to it, and most used sources will be available for you. Another useful feature is the use of an integration runtime. Integration runtime is a VM that sits in between your data and Data Factory as a kind of a proxy. The Data Factory then uses the integration runtime to ingest data. Integration runtime can help you for data that sits behind firewalls, data that's on-premise, data in virtual networks. And it can also help you in that way to ingest the data more easily. Data pipelines can be set up in Azure Data Factory as well, and they come with some useful features. So we can use Data Factory for orchestration um, as well as monitoring. So you can set up a pipeline, and then you can say how you want to trigger the pipeline, how every component in the pipeline is connected to each other, and when they should run. And afterwards, you can monitor every aspect of it. Data Factory can be backed by a Git repository, both on GitHub as well as Azure DevOps, and it allows us to use versioning. You can set up different branches, pull requests, and yeah, some rules in your organization for validation of a pull request. So it's a good way to benefit from the infrastructure as code way of working as well. Another service that we will be using is Azure Data Lake Storage Generation 2. This is a feature inside an Azure Storage account. It's basically Azure Blob Storage with some extra cool features enabled. The most important one is hierarchical namespaces. If you store something in regular Azure Blob Storage, it stores it in a flat storage, so there are no directories or folders or anything like that. And the benefit of it is that if you have hierarchical namespaces enabled, you can do actions that you would perform on a folder more easily, and especially if they will run a lot faster, because the Azure services will notice that it's a folder and they can just perform directory options like you can do in a regular file system. Why is this an interesting service? Because it allows us to store up to 4.75 terabytes per object and even more than 5 petabytes per storage account. You can even ask Microsoft to increase it if you ever hit the limit, but that's enabled by default at 5 petabytes. Another useful feature of storage accounts here is that we can set up lifecycle policies. The data will then move from hot to cool or to archive storage after it's been sitting in a data lake for a while. This can be useful, for example, you don't want to access the raw data every day properly, or at least the one that has been transformed in a previous pipeline run. And that way you can save a lot of money by using cheaper storage options. The next service that we will be using is Azure Databricks. Azure Databricks is like the regular Databricks, but it's hosted on Azure. Databricks is a solution that offers you managed Spark with some extra features that are useful for most data engineering work. One of them being notebooks. So you can write notebooks inside Databricks that will use a Spark cluster that the Databricks is hosting. If you haven't heard of Spark, Spark is a service or a platform rather that uses in-memory data processing. So Spark separates the storage from the compute. It uses regular storage options like Azure Storage or AWS storage for storage, and then it uses a VM cluster of VMs that will be used for the compute. This cluster has auto-scale and auto-termination on Azure, which will make it a little bit cheaper and easily scalable. So you can say like for startup use at least 2 workers, but then auto scale to maximum like 10 workers during execution. And if there is no activity for at least 1 hour, then terminate the cluster. And Azure will automatically spin up and spin down the cluster and create extra VMs if needed. Azure Databricks also comes with Git support for the notebooks. So like in Data Factory, you can create branches, pull requests, and validate them. Another service that we will be using is Azure Cosmos DB. Azure Cosmos DB is a global scalable NoSQL database on Azure. This is used for metadata storage. Metadata storage is needed when you store something in a data lake. You have to know where it's stored, and storing the metadata helps you to query all the available data in the data lake and to easily find where it's stored in the storage account. Another possible use of our Cosmos DB is as an integration endpoint. So when all the data is transformed and ready to be used in dashboards or reporting tools, you can talk to Cosmos DB using the SDKs that it provides and the APIs. There are SDKs for the most popular programming languages, and it has a RESTful API that you can talk to query the data. Azure Cosmos DB is also very redundant and performant. It can easily be scaled globally. You can scale to every Azure data center. And it can also be very redundant in that way. If you need it in another format, instead of NoSQL, you want to use graph databases, you can do that as well on Cosmos DB because it supports the Gremlin API. And then Azure Science Analytics. First off, Azure Science Analytics is actually a rename of Azure SQL Data Warehouse, but right now Microsoft is in sort of a transition period. It can be confusing at times. There is another service called Azure Science Analytics Workspace. This is in a public preview. This offers you a serverless SQL and serverless Spark. And it even includes all the features that Data Factory has for the pipelines and the data sources. So in the end, the goal is to replace all the previous services with this one, but it's not yet available for production use cases. But if you look up some documentation about Science Analytics, you will probably come across this. It's important to know there is a big difference between the current one and then the one that's coming. There's another feature called Azure Science Link. It's used for live analytics on database, on operational database like Cosmos DB or MySQL or Postgres. This is also in preview and is also not related to the existing Azure Science Analytics. How we will use Science Analytics in this data lake is as an integration endpoint. So we will store the transformed data that is ready for our dashboards inside Science Analytics. There can easily be queried, and we can connect it to Power BI, for example. Why Science Analytics? Well, in the end, your data lake might grow a little bit larger and you need some extra performance on this part. Well, Science Analytics offers massively parallel processing. Queries are executed on 60 instances. Well, that is if you distribute and partition your data correctly. And Azure has a feature called Data Movement Services that provides interconnectivity between these 60 instances to quickly move the data for quick computation. Another useful feature of Science Analytics is Polybase. Polybase allows you to connect to various sources. For example, our storage can be connected to Azure Databricks. It loads the sources as external tables, so you can query them like regular SQL tables, as if they were just part of your data warehouse. And from there, you can easily ingest them to your data warehouse as well. And then the final component here is Power BI. Power BI is Microsoft's dashboarding tool and reporting tool. It's a desktop tool, so it can be deployed using our Terraform module, but we provide you some helpful guide on how to do this. And we also have a pre-built dashboard that you can connect to our sample data. So these are all the components of our data lake. We provided a sample data pipeline to demonstrate how this works. It starts with the data factory, and then we go to the raw storage in the data lake storage account. We use a Databricks notebook for data cleansing. Then the cleansed data is stored in a separate container. And then in the data transformation phase, we also use a Databricks notebook. And after the transformations, the data is stored to Synapse Analytics and to the transformed container on our storage account. From there, we present it in Power BI with a connection to Synapse Analytics. And we also provide a Databricks notebook that can easily display all the data. This is probably easier for most developers, as the notebooks can be deployed using Terraform, so you don't have to do anything manual after deploying, and you can validate that the data is there. This is an overview of the components between the different kind of way of looking at it. This also shows why we picked the components that I've talked about. This is an architecture pattern provided by Microsoft on the Microsoft's Azure architecture documentation website. We see in their sample that I also ingest data from different sources with Data Factory and then store it on data lake storage. And from there, you can basically use all the components together. You can connect them directly. You don't have to follow all the different steps that we do, but we think that our example is a little bit easier to understand and to work with when you're just starting out with a new data lake. In this example, you also see that Cosmos DB is used as an integration endpoint for web application, and I don't have the metadata. But I use Azure Analysis Services, which we aren't using here. In the example, you can also see that they use Azure Databricks to prepare and train a model so that we can apply some machine learning to it as well. Now, how did this all come together? You built a module with Terraform. Terraform is an infrastructure as code tool. It's platform agnostic, so you can use it with Azure, with AWS, with Google Cloud, and it offers support for most services on Azure, on GCP, or on AWS. Terraform allows us to use infrastructure as code. So this means that we store all the configuration, all the management of the credentials of access control, etc. As code in a repository, and we can version it. And you can benefit from this in a couple of ways. It's easier for collaboration in a bigger team. It's easier to look up what has been configured in your infrastructure, and using the history, you can find out when it was being provisioned and why. And yeah, this is basically a lot easier to work with if you're doing big projects like setting up a data lake. Terraform has two important components. One of them are the providers. The providers connect directly to a cloud or a service or an API. We use providers for Azure resource management. This will provision all resources of our data lake. We have another one for Azure Active Directory for the access control management. Another one for Databricks, which will talk directly to the Databricks instance that we've provisioned to set up the sample notebooks. We've built a Terraform module. What is a module? A module is a kind of building block for infrastructure. So you can use it in two ways. Either you can use it inside your own infrastructure. So this means that you set up all the things that you need in your infrastructure, and then the module will be a part of it, and you can connect to it. Or you can deploy the module by itself. So this means that the module doesn't connect to anything else, but you just directly provide all the input variables needed to deploy the module. So this means that when you're using the module by itself, as we will do in our demo, you just have to type Terraform apply at the end. And this command will start the deployment of the complete data lake network. So this means that every component that you've talked about will be deployed. All the components will be configured to talk to each other. We have credentials, tokens, permissions, all the required rules set up for you. And optionally, you can even deploy a sample data pipeline. Now, all those different components require some settings. You can set them with the module. We provide a lot of configuration options, but you also have some defaults for the lowest pricing options to get you started. The module is available on our GitHub account, so this is the URL. It's open source. You can do with it whatever you want. You can contribute to it if you have some feedback for us, some issues, some suggestions. We have some documentation to get you started and to make sure that the quality of the module stays where it is, that it's stable. We have automated testing set up using GitHub Actions and TerraTest. So you're free to use a module however you want, and if you need any help, you can always contact us, and then we will help you setting it up. Now, the sample data pipeline that I talked about, this is a sample pipeline to demonstrate how our data lake module actually works. It's not focused on the cleansing and transformation of the sample data, because here we want you to notice how the data lake is working and not how all the different steps inside of it can be executed, but you just have to understand how it offers you to connect all these services together and how it can save you a lot of time. If you would do this manually, you would probably need a week or two to set it up. The sales data in our sample data pipeline is provided through an HTTP source. It generates fake sales data every time you run a data pipeline with a department, a country, an amount of a transaction. And we can use this in our dashboard after the cleansing and transformation. That looks something like this. So I've made a quick dashboard to demonstrate that it can connect to the transformed data storage. So it's sales data, and here you can see, for example, all the sales with the highest amounts. We can see the country in which most of the sales, the sales with the highest amounts have been done. You can see some of the total amounts in this example. You see that the biggest amount spent was on toys, and we have some kind of ratio to determine which departments have on average higher sales amount per sale. Now I think it's time for a demo, enough talking. So let me go to the module. So like I mentioned, the module is on our GitHub account. If you go to GitHub and you search for data roots, or you can use Google, or you type the URL directly, you can find a module. It has a README that explains everything that I talked about here, the Microsoft architecture, how you can use it inside your own infrastructure as a module. We've hosted it on Terraform registry. So if you go to the Terraform registry, make it a little bit bigger. There you can find the same documentation as well with the required inputs and outputs. If you want to use it, there are a few requirements. Now, most of them won't come as a surprise, but some of them you know too. So you need to configure the Azure providers. So this means you basically have to either log in through the Azure command line interface or set some environment variables to connect to your Azure subscription. You need to have PowerShell installed. It's cross-platform now, so you can do it on every machine. Reason for this being that we have some workarounds to connect to our Analytics workspace, Analytics instance to run some SQL scripts to initialize all the connections. And an other important one here is that you install the Databricks Terraform provider. This is a new provider that's being developed by Databricks in the Databricks Labs account on GitHub. It's still in kind of an early version, so you have to install it manually using this command on your machine that will be executing the Terraform commands. And they're developing it, like you see right now. You see last progress March 23 hours ago. So it's still a little bit rough, but it's already usable for our data lake. Now, let's clone the data lake module locally. Let me see. So I've done that already. So if I do an analysis, you can see all the files that are on the GitHub as well. Now, how do we start with it? We run Terraform init. Terraform init initializes our module by downloading all the required providers that we need and checking everything that we need is there. So it's been successfully initialized. Now we can run some other Terraform commands. One of them is Terraform plan. As you can see in my previous sessions, I already did it a couple of times. And in my Terraform plan, I supply some vars that will be used for the configuration. Now, which configuration? Let's see. On our README, you can find a basic usage, but you can also click through to a page configuration, which has all the possible configuration options, with some examples and some documentation on what they do. The most important ones are the region and the name. And these ones are all required. This is because these configuration values determine the pricing, and we don't want you to set up something with very high pricing and then have to find out at the end of the month when the bill comes. So from the start, you provide these values yourself. And we have some defaults that you can use when you use it as a module. These defaults are in the file called terraform.tfrs. And like you see, you have the lowest Cosmos DB throughput that you can use. You have the lowest data warehouse setting for pricing. So these ones will probably cost you the least. Now I will go with the defaults. There are two variables that aren't set yet by default. These are the username and the password for the SQL server that will host the Synapse Analytics instance. You have to set these manually because in most use cases you'll probably have something like HashiCorp Vault or like Azure Key Vault to store these values, and then you'll provide them to the module using code instead of using it on the command line directly. But for demo purposes, it's easier to supply it here. So what I will also set is a data lake name. So let's call it DL, and which day is it? The 2nd of June. All right. And I want my Terraform plan to be outputted to a file called, let's say, tf. So now what will Terraform do? It will check your Azure subscription on which service is already there. It will check all the components you defined and the dependencies between them, and it will also create a plan that will be deployed afterwards. So let's go back to the first lines of that. Okay, I can go back. One of the first things that it outputted was that it will check your current IP before you think that I will be checking your IP address. This is just used by the module itself to create a firewall rule for the Analytics instance, so that all the SQL scripts that you need to run can be run from the machine that you're using to run your Terraform. So now you see that it will add 52 resources. It won't destroy anything or change anything. And we can see all the different resources that it will add. So these are a few database secrets that are needed to connect all the components to each other. This is a database cluster. Yeah, I'm going into all the details since this is just what we've been talking about over the past half an hour. So if we now do Terraform apply and we give it the plan that was just created, Terraform will just start creating all the resources. Now the region by default is East US 2. So let me go to my Azure accounts. Here it is. So if I go to my resource groups and I say location is East US 2, I don't have anything with that, of course. Oh yes, I do. So why is it not saying this? Okay, I'm just checking. So right now you can see that there's just the default Azure network working on my account. But if I go look at the logs, you can see that it should have been creating a resource group. So if I now refresh this, it might take a while. Sometimes it takes like a couple of minutes before your portal knows that the resource group is there. Come on. Maybe refresh the whole browser again. This is one that I created before, so don't know why it's still not isn't there yet. That has been created, and that's my subscription ID. So if there are demo bots that you have to be patient for. Maybe I can show you in the Azure command line that it's been created. So if I do Azure group list, you can see that yeah, this one, that the resource group for our data lake has been created in East US 2. And it's still not on. No, it's not on. Okay. Well, then continue with the one that I had deployed previously. So it's this one. There was an error previously deploying the Cosmos DB because of capacity reasons due to the Corona crisis. Microsoft is having some capacity issues for CPUs and like bigger instances like Cosmos DB. So that's what you just saw in my terminal, that it has been unable to deploy this. Usually if you wait an hour or so and then try to deploy it again, it works. But yeah, right now we don't have that much time. So I'll just continue with the resources that have been deployed. So the data factory is this one. If you click on monitor, you can see the data factory. And here it says that you're ready to use it. You already connected the Databricks workspace to it and our storage account. So if you just do a test connection, it should succeed. Connection successful, and same with Databricks. So this means that you can start building pipelines. For example, I want to run a Databricks notebook. and then I have to say which database service, this one, and now I can say which notebook I want to run my pipeline. I can do copy activities, for example, copy the data, and then when it's done, I want to run the notebook. And this way you can easily build some pipelines. And yeah, because of the Cosmos DB issue, we can't deploy the sample data pipeline right now. But you will see that our sample data pipeline looks exactly like this. So we have a copy data, and then we have our notebook to cleanse the data, and one notebook to transform the data. Scrub this. And if I go to the Databricks workspace, you can see that it should have a cluster. It's signing in right now. So this is why I was saying it's in less than an hour. Usually it takes only 20 minutes to deploy the complete data lake. But because of these issues that Azure sometimes can experience, it might take just a little bit longer. You don't have to do anything, you just have to run the apply command again. But yeah, sometimes you might lose some time with this. At least you don't have to you take a couple of weeks to set up the connections manually. So this is a cluster that has been created by the module. So you can see that I've enabled auto termination, auto scaling here. And if you look inside our workspace, there is a notebook that sets up some configuration for the connection to the storage. We have already ran this for you, so you don't have to do this. You can just start creating a new notebook and run it on your cluster. Like an example. And if you go to the storage, you can see there that it's created some storage containers. So this is the raw data, the cleansed data, and transformed data. And if you run the sample data pipeline, it would create a JSON file inside the raw data. It would then transform the data using Databricks and output it as Parquet files in the cleansed data. And then in the final step, it will output it in the transformed data. Let's take a look if I can see my resource group now. Yeah, right, now it's there. So I don't know why this happens, but the portal is sometimes very slow to react to some changes. Maybe this one has a Cosmos. No, Cosmos failed here as well. All right, so that's it for the demo, I think. Yeah. So these are all the components that I've talked about. You have the signups. Now, if you want to set up the Power BI, you need to have a Windows machine. I'm on a Mac right now, so I can't show it for you. But we have created this guide on our repository. At the end of the Terraform apply, it outputs these values for you. And you can use these inside your Power BI dashboard. We provided the dashboard as well, so it's here in the assets folder. You can find dashboard.pbix. And if you would then go through these steps, you open the dashboard, you get a notification saying, oh yeah, you can't connect to the server, basically because the server is a sample server that we've used, but it doesn't exist anymore. You go to your data source settings and you change data sources there, and you can change the credentials as well. And then in the final step, you press publish, and then it will be published to Power BI online, or you can publish it and use it locally. If you want to use Power BI online, you need Power BI Pro accounts, or you can use a 60-day trial. So that's it for the module. Let's go back to the slides. All right. are there any questions about the data lake module or the presentation itself? You can put them in the chat, I think.
Yeah, so far there are no questions, Sam, in the chat. But basically, if you have a data source and you use this, well, I'll call it easy way to set up a first data lake, you can just connect to this data source using Data Factory, which has a lot of connections,
Yeah.
and you get started.
Yeah, indeed. Yeah. So for a customer right now, we've deployed this data lake module, and all we had to do was open the data factory, click auto monitoring to open it, and then when you click on the pencil, you can get started, the connections, and there we have all the possible connections to data sources. I haven't heard myself from all of them, but in our current use case, you're using SAP, so you just click SAP and then provide the credentials and the name of the server. And if you want to use an integration runtime, you can set up one.
Okay, good. Yeah, so we will be posting the recording of our session on YouTube, and yeah, feel free to post any questions on the YouTube channel as well. So thank you, Sam, and thank you all for joining the webinar.
Thank you.